Hello everyone, this is YAMUNAA R, roll number 22I375 of BTech IT third year, participating in the RECode coding contest conducted by PSG Tech Coding Club. First, let me explain the problem statement given. We need to find the longest path in the binary tree where every node on that path have the same unique value. This path can be any path between two nodes, not necessarily passing through the root. The path length is represented by the number of edges, and for this problem, the path must consist of nodes that all have the same value. For this, the efficient approach is using depth first traversal to find the longest univalue path in the tree. Let me explain the step-by-step approach to solve this problem. First, we need to pass the input level order array to build the binary tree. Use -1 to represent null nodes while constructing the tree. Then perform DFS traversal from the root. For each node, recursively compute the longest univalue path for the left and right children. If the current node's value matches its left or right child, extend the univalue path by 1. Then keep a global variable maxLength to store the maximum univalue path length. Update maxLength with the sum of the left and right univalue paths for the current node. After traversing the entire tree, the value of max length is the longest univalue path length, which is our result of the problem statement. Now, let me explain this problem statement with the help of the sample test cases given to us. So, the user inputs a space-separated integers which represents the nodes of a binary tree. By using these integers, we are going to construct our binary tree with 5 as the root and 4 as its left child, 5 as its right child, and so on. Now, we have to recursively perform DFS traversal on the left and right subtrees to find the longest univalue path. First, by considering this path, we see that all the nodes in this path does not have the same unique value, so its path length is 0. Next, by considering this path, here also all the nodes does not have the same unique value, so its path length is 0. Now we are going to consider this path where here this node is null, so we can see that in this path both the nodes have the same unique value, which is 5, so its length is going to be 1. And by considering this path, we see that all nodes in the path have the same unique value, which is 5, and its length is 2. By taking the maximum of this left and right path, we see that this path has the maximum value, which is 2, so our result is going to be 2. Next, let's see this example. So the user inputs the space separated integers which represents the nodes of the binary tree. Here -1 represents the null or missing node. We have to recursively perform DFS traversal on the left and right child. So as we can see, this node 4 has its left child as 1 and left child as 4 and right child as 4. So we are going to add this path as both the left and right child has the same unique value. So we are going to add the edge of these paths. So the length of this subtree, the path of this subtree is going to be 2. And now when we perform DFS traversal on the right subtree, we see that this path also have the same unique value 5 and its path length is 1. By taking maximum of the left and right subtrees, the left subtree has the maximum path length as 2 and right subtree has the maximum path length as 1. By performing maximum, we get the output as 2. So let me explain the code. Let's break down the code into its components and explain what each part is doing. First, class definitions. Tree node class. This is a simple class used to represent each node in the binary tree. The variable val is used to represent the value of the node. Left reference to the left child and right reference to the right child. Each tree node represents a node in the tree. It holds a node's value and pointers to its left and right child nodes. Next, main class longest univalue path. The variable maximum length keeps track of the maximum length of the longest univalue path in the binary tree. It is updated during the recursive traversal of the tree. The longest univalue path function that calculates the longest univalue path in the tree. It starts by checking if the root is null. If the root is empty, then it returns 0. Otherwise, it calls the helper function dfs to recursively traverse the tree and calculate the length of the univalue. After traversing the tree, the function returns the maximum length of the univalue path stored in the max length. Then the function dfs. This method that performs a dfs on the tree. The goal is to calculate the longest univalue path starting from each node. If the current node is null, it returns 0. This means there is no path if the node doesn't exist. The function makes two recursive calls to DFS, one for the left subtree and one for the right subtree. Left path and right path store the longest path from the left and right subtrees respectively. The function checks if the current node has children and if those children have the same value as current node. If the left child has the same value, the length of the univalue path going left is extended by 1. If the right child has the same value, the length of the univalue path going right is extended by 1. If the values don't match, the corresponding path length is set to 0. The total path length through the current node is the sum of left and right paths. The maximum length is updated with the maximum of current value or previously found paths. The function returns the longest of the left or right univalue paths. This value is propagated upwards to the parent node. Next, tree construction using build tree method. This method constructs a binary tree from the input list of integers using the level order traversal approach. It processes the input array where -1 represents a null node. It starts by creating the root node and using a queue to help build the tree in level order. It checks if there's a valid left child and adds it, and if it checks if there's a valid right child and adds it for each node. This function returns the root node of the constructed binary tree. Then we have the main method. It reads the space separated input values from the user to represent the binary tree. It handles -1 as a marker for null nodes. The input values are passed into an integer array. The build tree method is called to construct the binary tree from the input values. An instance of longest univalue path is created and the longest univalue path function is called to find and print the longest univalue path in the tree. Next, we are going to see the time complexity of this function. So for building the tree, the time complexity is order of n, and for DFS traversal, the time complexity is order of n. So the overall time complexity of this problem is going to be order of n, where n represents the number of nodes, and space complexity. Space complexity is order of h, where h represents the height of the binary tree. Next, we are going to see some additional informations. If the binary tree has symmetric values in one of its subtree, it is possible for the longest univalue path to pass entirely through the subtree and not through the root. That is why the algorithm must compute the longest path from every node, not just from the root. A univalue path can include both leaf and non-leaf nodes, but a path can only continue if both the current nodes and its child share the same value. If two child of the node have the same value as the node itself, the univalue path can extend through the parent node. Some common applications. This type of problem is common in tree-based dynamic programming or divide and conquer problems. It requires breaking down the tree into smaller subproblems and combining the results. Some practical uses of this approach. Problems involving paths with the same value can be useful in various applications like networking, path analysis, DNA sequence matching in bioinformatics, or finding trends in large data sets represented by trees. So this is our result page. We can see that all the 2 sample test cases given is passed with this code, and all the 6 test cases are passed in the Examly platform. Thank you for watching this video.